So in this first extra credit section, this would be extra credit involving material from Unit 3. I'll go ahead and watch this video first, and then you can work on that extra credit quiz on Canvas. And it's in the module section under Unit 3 in the OST review. So this example says line segment AC has endpoints at -1 and -3.5 and 5, -1. Point B lies on line segment AC at 0.2 and then -3. What is the ratio of AB over BC? So what we're going to do with this one, again, it's really helpful, plot these points, okay? So I'm going to plot -1, -3.5, so it's kind of in the middle there, 5, -1, and 0.2, -3. That's kind of like right here. And that's really hard to see on a grid because their decimals are really close together. It's kind of scrunched. Okay? So what is going to be really helpful with this type of problem, particularly because there are decimals, is to use decimals. So in decimals, we're going to plot those points they originally gave us. Okay, we're going to plot -1 and -3.5. And you have to put parentheses, -1, comma, -3.5. The other point was 5, -1. Oh, not even inside my parentheses. 5, -1. And then the other parenthesis was 0.2. -3. So it kind of plots them for you, and it's very, very accurate. So I would suggest using decimals. And essentially what we're doing after we plot those points is we're taking the distance of whatever AB is and putting it over the distance of whatever BC is and dividing it in your calculator. Okay, so if it's helpful, again, you can use an expo marker on your test. Just label it A, B, C. So to find the distance of AB, again, we make a right triangle. The weird thing here is they're not whole numbers. So you have to think about where your points are moving when you make a right triangle. Okay? So our y value here, because we are going up, my y value is at -3.5. And I'm going up to my other point's y value, -3. So if we're going from -3.5 up to 3, -3, the distance here is just 0.5. Then I'm going horizontally, so I'm going to look at my x values. It will let me do that. I have to cut this. Let me do that. Cut. Okay. And then I'm going horizontally here. Okay, so you're going to look at your x values. Come on, there you go. So I'm going from -1 to 0.2. Well, I'm going to go from -1 to 0, which is the distance of 1, and then a little bit more, which is 0.2. So that length there is 1.2. So when I make my right triangle, I went up 0.5 and I went over 1.2. Oh gosh. Mark went a little crazy there. Okay, so when we do Pythagorean theorem, we're going to do a squared. We use Pythagorean theorem to find your distance. A squared plus b squared equals c squared. We get 0.5 squared plus 1.2 squared equals c squared. When we type that in, we're going to do 0.5 squared plus 1.2 squared, and we get 1.69. Square root both sides. I know we say don't square root to the very, very end, and that still is true. But when you get these weird decimals, I think it's okay to try to square root. Because if it's a perfect square and you can take the square root of it, do so. So I'm going to take the square root of 1.6. And I get 1.3, which is totally fine. I would write that as 1.3. If I got a whole number, like let's say you got like 17 and you took the square root, leave it as radical 17. Don't round. I didn't have to round here, so it's okay for me to take the square root of it and put it in the square root form. But if you have to round, leave it as a round. So then we're going to find the distance at the bottom, which is, this was A, this was A, and then this was, this point was C, and this point right here was B. Okay? We're going to try to find AB over BC. So now I need to find the distance from here. Okay. Well, again, this point right here is at point 2, -3. So I'm going up 1, 2. So the distance here is 2. Then I'm going over, I'm going to start from this far point. I went over 1, 2, 3, 4, and then I went 0.8 more. 1, then 2, then 3, then 4, and this is 0.8. So I went a total distance of 4.8. So I didn't go all the way to 0. I only went to 0.2. So going from 1 into 0.2, I'm traveling 0.8. Okay, so then I'm going to do, to find that distance, 4.8 squared plus 2 squared equals c squared. And when we plug that in, 4 point, well, let me, 4, I'm going to try to do it. 4 point, oh gosh, come on, graphic calculator, 0.8 squared plus 2 squared, we get 27.04. Again, try to take the square root of that, and it gave us a normal number. It gave us 0.52. So that's okay. We didn't have to round that decimal. If we don't have to round, it's okay to leave it in decimal form. So when we added this, we got 27.04. We took the square root, and when we took it, we got a decimal that we didn't need to round. So it's okay to leave it like that. So those are our two distances. We got 0.52, and we got, what? Oh gosh, my board is really off. And 1.3. Those are our two distances, 1.3 and 5.2. So we're going to write that ratio. AB was 1.3, BC was 5.2. And then divide that in your calculator. Can't leave a decimal over a decimal. So we're going to do point, I'm going to erase this so I can type it. We're going to do 1.3 divided by 5.2, and it gives us 0.25. So you can either write it as 0.25 or 0.25 as a fraction is 1/4. So that is the ratio, is 1/4. So you find the distance of the top segment, find the distance of the bottom segment, divide them, and write your answer as a ratio, as a fraction.